Welcome to EDU World Space.
Okay, so if the satellite is moving from west to east, which means it's moving in the same direction of the Earth's self-rotating. So the relative angular speed is equal to the angular speed of the satellite minus the angular speed of the Earth. And as we know from the problem, it's 1/12 revolution per hour. We know that the angular speed of the Earth is 1/24 revolution per hour, because 24 hours equals 1 revolution. Hence, we can get that the angular speed of the satellite is 1/8 revolution per hour, which, because 1 revolution is 2 pi radius, and 1 hour is 3600 seconds, and we get this answer for the angular speed of the satellite is 2.18 times 10 to the negative 4 radius per second. Okay, so the force between the Earth and the satellite is the gravitational force, which can be calculated by constant g, mass of the Earth times mass of the satellite, divided by the distance between the center of the Earth to the satellite. Okay? And this is also a centripetal force, so it's going to be equal to the mass of the satellite times angular speed squared times the radius r. So from this equation, we can express the distance from the center of the Earth to the satellite is equal to the constant g times, this is the mass of the Earth, divided by angular speed squared. And this whole thing to the 1/3. Okay? Plug in the number, you can know that is equal to 2.03 times 10 to the 7 meters. Remember, this is the distance between the satellite and the center of the Earth. We still need to minus the radius of the Earth to get the final height is equal to 1.39 to the 10 to the 7 meters. So for question B, the satellite is moving in the opposite direction, so the relative angular velocity is negative. So we're going to use this equation again to find that the absolute angular velocity of the satellite is negative 7.27 times 10 to the negative 5 radius. We're using exactly the same equation. The only difference is that the relative angular velocity here in question B is negative. So we have this angular speed of the satellite. We're plugging this equation we just get here. We're plugging it. We can get that the radius in question B is going to be 4.22 times 10 to the 7 meters. And the height is the radius minus the radius of the Earth is going to be 3.59 times 10 to the 7 meters.